So we are getting out to the end of our journey today. So last speaker is going to be José Fonseca. Okay. So José, he loves skiing. He loves to go to the snow and skiing. He is, for me, the definition of a tech guy. So if we are having lunch or in Mindera, and if you say to José at lunchtime, it would be very good to have this system or this feature on the system, he will pull a all night thing, and in the next day we'll have that feature or that system working. Is that that type of guy, that type of guy. So he was going for intermittent fasting diet, and the results was showing. He was looking pretty fit before the quarantine. Let's see on the image if the results still continue. Also, once I tried to drive Jose in my car a bit fast, and Jose was almost ruining my door handle. So every time I drive with Jose now, I always take the economic mode on the car, so to go slowly. Well, Jose is one of the founders of Mindera, and he comes here to talk with us about HTTP in a nutshell. Fascinating topic for me. Does that come in red also, Jose? Well, let's wait a moment and he will join us just right after this.
Everyone, I'm hoping that I'm already live now. Thank you so much for being here. I know this day got a little bit delayed. So my name is José Fonseca. I'm one of the founders of Mindera, and I've got a bit of a techie background. And today I'm here to talk a little bit about HTTP. We don't have a lot of time, so I'll try to rush through my slides quickly. Feel free to ask your questions on the chat, and we'll answer them in the end. Feel free to ask any questions if you want about Mindera, not just about my talk. So, right, let's jump into it. So, HTTP. HTTP is essentially an hypertext transfer protocol, and what this really means for maybe for the less tech people out there, what it means is that this is a protocol that defines the language that your browser will use to communicate with the server in order to obtain one of the pages. So this is used everywhere whenever you're accessing pages. And why make this talk today? Really, HTTP really represents between 55 to 70% of all of the traffic in the internet, and most of us developers they don't they don't really understand they build applications using HTTP, but a lot of people don't really understand the details of the protocol or the history behind the protocol. So I thought about putting this together to essentially give you a rundown memory lane, and it all starts in 91, so almost 30 years ago. So about 30 years ago, Tim Berners-Lee, which you might have heard of him as the creator of the World Wide Web, he put together the version 0.9 of the protocol. This was known as the one-line protocol, and it was essentially this line here. Get, and then you would specify a path. So there was only one method, there was no version in the protocol, and very, very simple client-server request-response type of strategy, and very simple ASCII text over a TCP/IP connection, and it was designed to transfer HTML. Now, I want to kind of point out that although this has been a very, very simple protocol, this really was the thing that seeded the World Wide Web as we see it today. And sometimes it can be quite humbling to think that such a very simple protocol can create such a dramatic change in the world. So then a few years later, the first browsers appeared, the Mosaic. I don't know, for those who haven't seen it, here's a screenshot of it. And HTTP was started to be published under its first RFC, but it was not yet an internet standard, so that took a little bit longer. And at this point, it was upgraded to version 1.0. So what are the characteristics of the version 1.0? So if 0.9 was just get and whatever path of document you wanted to have, here you started seeing requests being identified with a version, and some important headers were added, and version status codes were also added to the requests and to the responses, and you had a few new methods appearing, such as post and add. Another big change here, and probably the biggest change in all of this version, was the fact that clients could now send an accept header. And what this really means is essentially it's telling the server that I'm making this request, and in this case I can accept everything. Now the server, when it responds, it can specify using the content type header that the response that is sending is, in this case, text HTML. But the simple fact that there was a new header here to specify the type also allow the protocol to be used for transferring images, for transferring CSS, although I don't think CSS was a thing at this time. So if we move on and kind of go through what are the major issues with these first two versions of the protocol. And the first issue really has to do with the way it interacts with TCP. So every single request and response would require one new TCP connection. And the TCP connection, although it's pretty fast to create, is not really super straightforward. Essentially, here's the diagram that shows the handshake. And the handshake essentially goes like the client will send a SYN to a server, the server then responds with a SYN ACK, and then the client sends an ACK back to the server. So there's at least 3 communications that need to happen before a socket is established. Now, if you think that the client is in Europe and then the server is in the US, there's a lot of distance to cover, and of course light speed is fast, but there's still a lot of work to do. Now, if you have to do all of this work for every single request, that's a problem. Then that's sort of the frequent round-trip delays. Now, another one that's not so obvious is the slow start in the way it interacts with TCP, is being victim of the slow start algorithm. Now, TCP is essentially a mechanism for managing managing traffic, and it's got a lot of congestion management algorithms built into it. And you will see what this means when you think about like downloading a big file from the internet. When you hit the download button, and if you look at the download speeds, you will see that it always starts very slow, and then it starts speeding up really fast. And that's TCP working through its slow start algorithm, and it's limiting the number of bytes that are sent, or number of packets that are sent on each connection until the number reaches a certain point. Then it makes sense to not limit them anymore. But of course, HTTP requests are always very small. They are always at this slow start, so the interaction here with TCP for these 2 versions of the protocol is not very good. There's another one that's quite important we're talking about is the lack of support for the virtual hosting. Essentially, because you only make a connection to a server, and you do a get on a certain path, but you don't specify the domain that you're trying to get to. It kind of means that you can only have one website per IP address. So at some point in the past, when the internet started growing super fast, there was a fear that if the protocol was not upgraded, that we would run out of IP addresses at some point. Right, so and then in 97, version 1.1 of the protocol came around, and this was a really big game changer. I mean, so big that it's been around for so long now, and it has been a really stable protocol, which is good, but it's also bad, as we will see in a little bit. So this was the year where you also started seeing the proliferation of the web browsers, such as Netscape. Here's a picture of Netscape, Opera, Internet Explorer, and Mozilla. A few interesting things for those out there that are a bit more curious. If you if you want to read about some internet history, you can go read about the browser wars, or another interesting one is the history behind the user agents, because all of these browsers use the user agent string to sort of pretend that they were each other, to make sure that servers never limited the capabilities that they send. So there's some pretty interesting stories out there on Wikipedia. And right, so in terms of the characteristics for this protocol and sort of what changed between 1.0 and 1.1, sort of obviously the version changed. There were a few new methods being added, and the biggest change was really the capability to issue multiple TCP requests over the same connection. And that essentially meant that after you do a connection, you could keep the socket open. Now, all of the previous talks were so cool, and everyone did demos and so on. And I thought, well, I don't really have much to do. So I put together a very simple Node.js server here with. I'm not going to show you the code because it's really boring, but essentially it builds a very simple web server or HTTP server with using only the socket libraries. So I've got it running here on this tab. I'm hoping you can see this well. And if I connect to it, I'm going to show you sort of the differences here. So I'm going to just connect using Telnet. Obviously, a lot of people use tools such as Postman and curl and so on, and I like all of those tools. But I think it's very, very important for every developer to really understand how to write and read data raw from a raw TCP connection, and this is what tools like Telnet will do. So when I press enter, this will establish a new connection with the server that I've got running. So I want to show you first what is the one-liner protocol. So literally all I have to do is write this and just press enter, and that's it. I got my request through, and my server just responded with this, and then in the end it closed the connection, so I'm back to my prompt here. Now, if I use version 1.0, you will see that it will also close the connection. But with version 1.0, although by default connections were already being closed at the end of the request, you could actually use the connection header to tell the server to keep the connection alive, and that's what we'll try to do here. Okay, so now I'm going to write the connection header. Okay, that's it. Okay, right, so I got my request, I got the response, and see that there's a version now, and there's a status code as well with 1.0, but you can see that the connection is open. I'm not in the prompt again, so I can write another request there, and I can go like this, there, connection, close. And that's it. I send the connection close in the end, and I got that. And that's all I'm going to do for them. Otherwise, it's too risky. Okay, so a big deal here is the fact that this version of the protocol made SSL connections practical. Now, SSL has little to do, I guess, with HTTP, because really, an HTTPS connection is just HTTP running through a different pipe, one that is encrypted. But what happened is, if we go back to our TCP handshake slide, what happened, the reason SSL was not practical is if you had to make a new connection for every single request, which goes through these 3 steps. Now, if we add on top of these all of the steps, which I think are about 5 steps in total to do the SSL handshake, and then send a bit of data backwards and forwards, that would not be practical and would be extremely slow. And I guess with the HTTP 1.1 and with the fact that the connection keep alive was now a default, this became practical and possible. Another thing that was possible was HTTP pipelining, and I'll show this in a slide, in a few slides. But I want to talk a little bit about the upgrade header, because Bruno talked about that, and we didn't share the information, I didn't solve the details. By the way, Bruno, your talk was fantastic, but it was really, really spectacular. But Bruno talked about this and talked about WebSockets, and I was really pleased he did, because it really allows me to talk about the upgrade header a bit more. Now, what is the upgrade header and why it's so important? With this version, the fact that it came with the upgrade header, it essentially meant that this version of the protocol allowed the protocol to become anything it needed. So really, to use the upgrade header, what you're doing is that your browser is sending an HTTP request to the server, and then the server responds, and in the response the server will send an upgrade header and tell the browser what other protocols it can answer to or it can talk. Then the browser or the client will tell the server, okay, let's do an upgrade, and the server then upgrades the connection, and the same socket or the same pipe that was established between the client and the server can now be used to talk something other than HTTP. And this really opened the world to a lot of interesting possibilities. So I want to make a bit of a detour on the story of the protocol, just to show some practical things. There's only 3 slides. Just I'll promise I'll be quick on some practical things about the protocol that I think are quite important. One of them is HTTP compression, and this became possible through the use of the accept encoding and the content encoding headers. So a client will make a request, and within the request they can specify the accept encoding. Essentially, they're telling the server what sort of encodings they accept for the content. And in this case, it's specifying gzip, deflate, and br, which are different compression algorithms. And then the server, as it's making a response, it says, okay, if you understand gzip, well, I'm just going to gzip this content. And in the headers, it specifies that the content is now zipped, and this is what you get if you look through the pipe. You get all of the headers, and then you get these sort of nonsense characters that I can't read, but gzip can. Right, so it's important to talk about methods. I suppose at this point, really everyone should understand them all. I'm not going to explain each one individually. What I am going to do is I'll talk a little bit about the semantics and the importance of the semantics of the method. So there's 2 semantically important things to consider in your HTTP methods: if they are idempotent and if they are safe. And idempotent, if you don't know what this means, essentially means that if you essentially repeat the same request twice, it does not cause extra further modifications in the server. A few of us are involved with betting applications and gaming applications. So an example of this is an idempotent request is you make a bet, and then if for some reason that request is replayed, that bet is not replayed on the server. So that's what idempotent means. And safe just means that you can call it without fear of making a change on the server. This is obviously your get method is a safe method. Now, it's important to understand that these are semantics. The protocol is just semantics, and the implementations will be different, so you kind of have to consider the implementation before you can be 100% sure that a certain method is idempotent. And I can tell you that I have seen transaction applications using get methods to actually exercise transactions, and I don't know what kind of led the developers behind those applications to make them like that. I'm sure that they had certain constraints that they couldn't get past, but that was a bit scary to watch. I'm not going to talk about all of these just for the sake of time. Maybe I'll talk about some of the ones that are a bit less known. I'll talk a little bit about maybe the connect, which you might not have seen used anywhere. So this is a method that is kind of similar in a way to the upgrade, because you can essentially make a connect method and specify a different server that you want to connect to. So technically, you should be able to use a connect through an HTTP request, use a connect method to establish an SSH connection to a certain server, for example. So let's move on and talk a little bit about the response status codes. Again, you're probably quite familiar with these, but essentially the status codes are grouped in these 5 categories. The 200s is where you have your OK statuses, so obviously the OK, telling the client that a certain piece of content was created, telling the client that it's sending it a partial content, or that the content is accepted. A partial content, I'll talk a little bit about this one, because you might not have seen this one, it's not that common, but HTTP provides these some methods, but some interesting headers. One of the headers is the range header, where you essentially can make a call for a document and specify sort of the minimum byte and the maximum byte that you want. So you can sort of download the document in chunks, for example, or you can use it to maybe go back on a video that you were watching, something like that. So this is where the server, instead of sending you a 200 OK, would send you a 200 partial content, telling you that it's only sending you a portion of the content. The 300s is where you have your redirection messages, the sort of things like, well, you're trying to make a request that can't be found here, it can be found somewhere else. Or another one that's quite important, again, you might not have seen this, but it is used a lot if you look at your network tab on your browser, is the not modified status code. And what the not modified status code is sort of is a way for the server to tell the client that the content that the client is trying to get has not been modified. Now, how does the server know that the client as a version of the content that it somehow needs, how does the server know that the client already has the piece of content? So, and that's achieved through the e tags. So when you get a document, and you might get a 200 OK response with the document, attached to that might be an header specifying the e tag. Now the browser, when it's asking for the same content again, it will send that e tag along with a few other headers to specify the conditions in which the server should respond with not modified. And that's pretty handy, because when the server is sending obviously this, it will only send a partial part. It will only send the headers, and it will not send the content, so the traffic will be quite reduced. And so I think that was all for the tour. I only had these 3 slides. Oh, sorry, we still need to talk about the 400s and the 500s and the 100s. Sorry, I jumped the gun there. All right, cool. So 400s is simple. It's just about telling the client that there's a problem and that the problem is on the client side. Maybe the client has sent a request that was not correctly structured, or the client is trying to get something that it's got no authorization for. And the 500s are essentially a group to tell the client that there was a problem with the request, and the problem was on the server side. Maybe it was an internal error, maybe there was something that should be implemented but it's not implemented yet, a service unavailable, quite important status code to send back whenever your server is under load, for example, because usually attached to this status code is an header where you can specify the number of seconds that the client should wait before they try to make another call. And this is actually really important, and I don't see it being used enough, because usually when a server is under load, a client gets an error, so the client will just retry that. And if you've got a bunch of clients, or maybe in the example of Bruno that Bruno gave with the poller, if you've got a bunch of clients with a bunch of pollers, they're essentially not allowing the server to recover because they keep on bombarding the server. So this is a nice way along with the retry time. Now I saved the 100 to the end because this one is really less common, and you for sure most of you have not really realized that these even existed. And this is all about sending informational responses. This is where the status code that the server would use to confirm that it is switching protocols. In the example that I gave for the the WebSocket upgrade, but it can be other things. The continue is also quite interesting to talk about, and you can think of it. So if there is, let's say that I'm making a request, but let's say that I'm trying to upload a big file, okay, and my content type is a PDF. I'm going to upload a PDF file. It's got 100 megabytes. Now, it really sucks that I upload 100 megabytes and then I get to the end and the server tells me, I'm sorry, but we don't take PDFs. And I think this has happened to a lot of people. It has happened to me as a user, but also has happened to me as a developer implementing these sort of things, because I did not realize that you could do things like that. And one of the things that your client could do is to introduce an header in the upload when it starts sending the requests, saying that it expects the server to send me a continue. Okay, so what will happen in this case is that as I send my request with my header specifying what am I expecting, and I'm expecting the server to answer with continue, it gives the server an opportunity to look at my request and either send me a response, an intermediate informational response status saying yes, continue, or send me something like a 400 saying, well, you're doing a bad request, for example, and that would save the client from having to upload that huge file. Okay, now I think we've covered all the states. We can move on from the detour. So if we go back now to the HTTP 1.1 and the performance issues, although you could do this sort of thing here, and I said I had an image for HTTP pipelining. This is what HTTP pipelining is. Between a client and a server, you establish one socket, and the client can send one request, another request, another request, and then the server can process these requests serially. And this is what pipelining is. Now, this is fantastic. For what it gave us, it's really been very, very good. But it does suffer from this head-of-line blocking, where essentially the server and the client, they need to wait for these requests to be fully completed before sending the next one and sending the next one. So if you're sending 3 requests, and if request 1 happens to be really, really slow, all of these other requests are they're going to take as much time as that request 1, and maybe you should have changed the order, for example. Now, another big one is also the header compression, the fact that it doesn't exist. So if we go back to our compression example, yes, we told the client that we were ready to accept compression. Yes, the server told us that it was compressing the content, but look at just how big these headers are. So these are not compressed. There's repetition of information. Again, for every request, headers and cookies are always sent, and I think this is less common now, but I used to see a lot of developers using cookies as a way to store content, and obviously that's wrong, because essentially you're sending the storage from your browser to your server on every single request. Now, over the years, these things have been minimized, all these problems with header compression, with repetition, and so on. And this is one of the things that has been good for HTTP 1.1 and has allowed HTTP 1.1 to live for so long, because developers really found ways to go around this. And you'll be familiar with bundles and CSS sprites and so on. All of that creativity has been really, really positive there. Now, it also means that the fact that so many optimizations on the way to use a version of a protocol were done outside the protocol, it means that the protocol puts the protocol in a position where it's much, much harder to evolve, and that's kind of what has happened with HTTP 1.1, and that sort of takes us to the next slide where we talk about HTTP 2, and HTTP 2 is essentially it's a new expression of the same semantics, for lack of better wording. So it allows you to use bidirectional streams to communicate with the server. So when in HTTP 1x you make a server request and you get back your responses. Here you can make a request and then get back a number of files, for example, within the same connection, and they no longer need to be ordered and in sequence. And here's a better example. So this really improves the performance there. So it's a binary. It's no longer a textual protocol, so I can't really show you now with Telnet. I can no longer write that. It's fully multiplexed, and like I said, it's ordered and it's non-blocking, so you can make all of your free requests there, and the requests can be served really regardless of the order that they were sent in. And this is quite important, the fact that multiple files can be served in parallel over a single connection, and it uses header compression, which will reduce the overhead a lot. And the servers can now push information to the browser. Now, let me just check so just before we go into the performance issues, not just performance issues, the issues as a whole. I think one thing to keep in mind is that this has been around for a few years now, 5 years now, and I don't think we hear a lot about HTTP2, or we don't hear as much as we should. You see HTTP2 when you're looking at your network tabs, but HTTP2 has been sort of implemented by the world sort of as a layer between your server, a layer that usually sits at a load balancer, or maybe it's Cloudflare that's in front of your server, and your CDN is there making a conversation in HTTP2 with the client, but kind of all of your server infrastructure and application, microservices and so on, it's all still built using HTTP 1.1. And I think there's a reason for that. And we'll get into that when we look at the issues. But essentially, the reason we don't see it that much, it's because the process of transitioning to HTTP2 is really hard, and I think that's one of the issues. So I kind of scratch the performance aspect here and just generally talk about issues with HTTP2. Because there's been a lot of criticism around the web about this. Mainly, I think it all goes around the fact that it was built under an unrealistic short schedule. It should have taken longer, and I think it should have taken longer so that better thought could be made around the process of transitioning to this version of the protocol. And a lot of the techniques that we're using to make the performance better on HTTP 1.1 are actually now hindering the performance of HTTP 2. For example, domain sharding, which is essentially serving your assets from different domains so that your client doesn't always send the cookies and so on to all of these. And also, if you're loading in data from 3 or 4 different domains, or images or assets from 3 or 4 different domains from your browser, you get less limited by the fact that the browser will only want to do like 5 or 6 concurrent connections to any single domain. And things like concatenation, the fact that we make these huge bundles, they're not worse with HTTP2, but the benefits that you would have maybe you could, if you broke those bundles into smaller bundles, maybe instead of having one big bundle for your entire application, maybe smaller bundles, one for each module, you would get a lot better performance from HTTP2. But really, we know that HTTP2 can do a lot more than just improve the way data is sent over the channel. You could actually have your server sending data. For example, you can receive a request to an index file, and then in the response you can send the HTML, but you can also send the response for a data request that the application will do as soon as it loads. So in this case, the application will do that, but the data would already be there because it's already been sent by the server. So this sort of maybe cleverness that could be implemented on the server side to really take advantage of HTTP2 is not being done. And another one that has generated a lot of criticism with this version is that although HTTP2 does solve the head-of-line blocking at the protocol level, at the HTTP level, because it still uses TCP, well, it still suffers from head-of-line blocking at the TCP level. And this is now been really recognized as a design flaw. And that sort of takes me to my last slide, and this is HTTP free. And you'll see we're already talking about HTTP free, and we haven't even rolled out HTTP2 properly to our applications. But I think it will be a worthwhile jump. And I'm actually glad that we're not just talking about it. I'm glad that this is a thing for more than a year now. So in November 2018, HTTP over QUIC was converted into HTTP free. And QUIC was a protocol developed by Google. And really what this is essentially TCP plus SSL plus HTTP, all of these things combined, implemented over UDP. And when I talk about HTTP free, I do this workshop at MINDERA. It's a full-day workshop where we go through a lot of the topics that I cover here in a lot more detail, and we build our own servers and so on. Everyone's first question is, well, TCP is reliable and assures that packets are delivered. How can we build something over UDP, or because UDP is kind of known for not being reliable? Which is really not true, but UDP is essentially a fire and forget mechanism. You send a packet to the network and you forget about it. You're not waiting to have an acknowledgement that was properly received. Now, the reason to do this over UDP, I think, is quite good, and I think it will be worth it. I don't know more about the details of QUIC, but the reason is that TCP, if you think about kind of TCP and the way it does all of these congestion mechanisms, and and the fact that it's implemented across so many devices, like all of our laptops, maybe our routers, like everything really that talks to the internet over TCP has got these algorithms built into it. And it's not just there for HTTP; it's there for a lot more than HTTP. But one of the things that is hard is we can never, as a community of developers, we can never upgrade TCP to something better, or something that better aligns itself up with HTTP. Maybe there was a flag where we could say to TCP, look, I'm doing an HTTP request, don't apply the slow start, for example. Well, something like that could never be achieved because the rollout of that would be impossible to do. So it does make sense to essentially pick up a transport protocol that is incredibly light, allows for faster connection times, and you can build congestion control on top of that into this QUIC layer. So you could build the congestion control there. And the congestion control could now be built specifically for HTTP, so it could be much better. Now, Google states that already 50% of the requests between Google Chrome and Google servers are already using QUIC or HTTP free, which is fantastic. In September 2019, HTTP free was added to Cloudflare and to Chrome Canary. Now, I don't know if this has made it already into the stable release of Chrome. It's something to check. But I think this is all I had for you guys today. Just a quick run through the various aspects and the history of the protocol. I hope you enjoyed this. So I'm going to check the stream now. Hopefully everything was nice. I'll check the stream to see if there were any questions there. Let me just take a quick look here, guys. So I don't know if I'm looking at the right place or not. Okay. Right, okay. So we've got a question from Raul here. The question is, since you study and research about HTTP, do you see benefits of the upcoming HTTP 3 in any of the MINDERA projects, like heavy data exchange ones? The answer is yes, yeah, of course. I mean, there's a reason why I do this as a workshop, as a one-day workshop internally in the company, is that I want everyone to really be aware of the fact that that all of these aspects exist around the protocol, because I think the more we know about it, the better we can make use on applications. And like I said, I think this aspect of both HTTP2 and HTTP3, this aspect of the server side of things, where the server can push data to the client during the requests, or those aspects, I don't see them really being well explored. And if you search online about this sort of performance of big bundles versus medium-sized bundles versus essentially no bundles at all, just individual files across the different versions of the protocol, you will see that with HTTP2, sort of medium-sized bundles and big bundles are still better, but the point, those tests, and I don't bring those tests into the talk here, is that those tests, they focus on transfer speed, but transfer speed isn't really not everything, because we have to consider cache invalidation, for example. When we have these big bundles, well, they get invalidated all at once with a very small change. You know, if you have a website where you're doing weekly releases, you're changing the bundle weekly. If your users only go to your website once a week, well, they kind of will have always a slow experience, or a slower experience. Other aspects is that the fact that you're sending everything as bundles, it sort of doesn't make it easier for you as an application developer to focus on sending just the most important things first, to really improve that time to interaction with your application. So I hope I answered your question, but essentially the answer is yes. Please, let's get this going. Let's use this. Okay, so let me see if there are more questions. So a question from José Silva. In your opinion, do you see HTTP3 reach a stable or become a standard in the next couple of years? Hard to say. I think not. I think it will take more than that. I think it will. You know what I think it will take? I think it will take something. Some big sort of frameworks like Spring or Express in Node to really take a big bite out of implementing something around HTTP 2 and HTTP 3 to really make use of the big thing, like just instead of just focusing on improving the transport layers. So I think if something like that happens, I think we will see something. We will see a much faster rollout. But I think 2 years might be a bit too optimistic. Okay, so we've got a comment from Lars. Wow, Lars, hey man, long time no see. I'm happy you came around to see the talk. Yeah, I hope you enjoyed it. Right, and something you point out, the browsers even have limits on the same hosts, and so small bundles have issues as well, which is true. But remember that when you're doing an HTTP2 or HTTP3 connection, those limits are not so relevant, because you can actually transfer multiple files at the same time through the same pipe. So yes, but yeah, I think those two things are not necessarily correlated. All right, so I'm the last person in this making a talk, and I can see that there are no more questions. So I wanted to just take maybe a couple of minutes to really thank everyone that's been out there watching. I don't know how many people were. I mean, at some point there were more than 200 people. I think kind of people started tailing off throughout today. But it's funny, like we're working from home, and we're doing sort of this event in a really difficult way, trying to get all of these various streams to combine into one and then ship it to YouTube. All of you people out there watching, it's actually, I think it's one of the most attended tech days that we've done. So I'm really pleased about that. Oh, hang on, there's another question from Carlos Castro. Do you think HTTP methods and status codes are well adopted in the web? Mm, yes, I think so. And it's all Carlos. It's all about semantics, right? And I see that there are a lot of situations where people kind of struggle to really where people struggle to decide which status codes to use or which methods to use. But I think generally people have a reasonably good idea. Usually it's only when you get to edge cases, and semantics is also up for interpretation. So I think the answer is yes, genuinely. Now, could it be better? Yeah, sure. I think so. I think it could be improved. Okay, there's more questions popping up, guys. I was doing the kind of the wrapping up, but you guys are asking more, and I recognize that there's some delay here in the feed, so I'm sorry about that. So from Ricardo, hey Ricardo, how are you, man? What would you change on the HTTP protocol? Oh wow, what would I change? That's a really good question. I don't know that I've thought about that to really think about the change that I would do. Yeah, so I don't think I wouldn't change anything. Maybe if I think about it a bit more, but on the spot, nothing really comes to mind. I'm sure that if I sleep on it, I'll have some ideas. So, right, so I'm not sure, again, hopefully I think that was the last of the questions. So, right, I mean, back to wrapping this up, guys. Huge thank you to everyone that's out there, but also huge thank you to everyone that's really got together to organize this. You guys have heard about Fernando. He did that really awesome talk at the beginning about React, and he's been doing all of this cool work to get all of the streams together. He speaks to people via Zoom calls and so on. So it's really nice, and has been going well so far. I think hopefully I'm not going to screw this up in the end. But also, I think, like I was saying, in this, it's a weird time where we make a tech day, all virtual, all people working from home, and it ends up being one of, if not the most attended day. I think it's really pleasing to be part of this, and throughout this day we've also been publishing this charity that we're trying to raise some funds for. If you've donated already, we don't see the donations, they go straight to the charity. So if you donated already, thank you very much. I think they will be massively appreciated that you've done that. If you haven't, consider donating. If you've learned something today, just let's help people that can't help themselves, and I think this is what this charity does. I know personally that they are really struggling with the pandemic. They're not as fortunate as we are. So I would say, look, if you learned something today, if you enjoyed the day, and obviously if you can afford this, of course, please donate to them. And I think that's really all that I would have to say. So I would say then, thank you so much, everyone. It's been a huge pleasure to have you all. I hope we can do more of these. I think that the situation that we are in with COVID and the virus, I think it will bring a lot of change to the world, and I'm hoping that there's a lot of good learnings and a lot of good things that we can do, and definitely doing more of these sessions is something that we will, maybe we'll do smaller versions with just 2 or 3 talks, or maybe we'll do an even bigger one. Let's see. So guys, thank you so much, and we'll see you around soon, maybe in the next virtual tech day.